What is computer networking? Computer networking refers to interconnected computing devices that can exchange data and share resources with each other. These network devices use a system of rules called communications protocols to transmit information over physical or wireless technologies. How does a computer network work? Nodes and links are the basic building blocks in computer networking. A network node may be data communication equipment, DCE, such as a modem, hub, or switch, or data terminal equipment, DTE, such as two or more computers and printers. A link refers to the transmission media connecting two nodes. Links may be physical, like cable wires or optical fibers, or free space used by wireless networks. In a working computer network, nodes follow a set of rules or protocols that define how to send and receive electronic data via the links. The computer network architecture defines the design of these physical and logical components. It provides the specifications for the network's physical components, functional organization, protocols, and procedures. What do computer networks do? Computer networks were first created in the late 1950s for use in the military and defense. They were initially used to transmit data over telephone lines and had limited commercial and scientific applications. With the advent of Internet technologies, a computer network has become indispensable for enterprises. Modern-day network solutions deliver more than connectivity. They are critical for the digital transformation and success of businesses today. Underlying network capabilities have become more programmable, automated, and secure. Modern computer networks can operate virtually. The underlying physical network infrastructure can be logically partitioned to create multiple overlay networks. In an overlay computer network, the nodes are virtually linked, and data can be transmitted between them through multiple physical paths. For example, many enterprise networks are overlaid on the Internet. Integrate on a large scale. Modern networking services connect physically distributed computer networks. These services can optimize network functions through automation and monitoring to create one large-scale, high-performance network. Network services can be scaled up or down based on demand. Respond quickly to changing conditions. Many computer networks are software-defined. Traffic can be routed and controlled centrally using a digital interface. These computer networks support virtual traffic management, provide data security. All networking solutions come with inbuilt security features like encryption and access control. Third-party solutions like antivirus software, firewalls, and anti-malware can be integrated to make the network more secure. What are the types of computer network architecture? Computer network design falls under two broad categories. 1. Client-server architecture. In this type of computer network, nodes may be servers or clients. Server nodes provide resources like memory, processing power, or data to client nodes. Server nodes may also manage client node behavior. Clients may communicate with each other, but they do not share resources. For example, some computer devices in enterprise networks store data and configuration settings. These devices are the servers in the network. Clients may access this data by making a request to the server machine. 2. Peer-to-peer architecture. In peer-to-peer, P2P architecture, connected computers have equal powers and privileges. There is no central server for coordination. Each device in the computer network can act as either client or server. Each peer may share some of its resources, like memory and processing power, with the entire computer network. For example, some companies use P2P architecture to host memory-consuming applications, such as 3D graphic rendering, across multiple digital devices. What is network topology? The arrangement of nodes and links is called network topology. They can be configured in different ways to get different outcomes. Some types of network topologies are bus topology. Each node is linked to one other node only. Data transmission over the network connections occurs in one direction. Ring topology. Each node is linked to two other nodes, forming a ring. Data can flow bidirectionally. However, single node failure can bring down the entire network. Ring topology. Each node is linked to two other nodes, forming a ring. Data can flow bidirectionally. However, single node failure can bring down the entire network. What are the types of enterprise computer networks? Depending on the organization's size and requirements, there are three common types of enterprise private networks. Local Area Network, LAN. A LAN is an interconnected system, limited in size and geography. It typically connects computers and devices within a single office or building. It is used by small companies or as a test network for small-scale prototyping. Wide Area Networks, WAN. An enterprise network spanning buildings, cities, and even countries is called a Wide Area Network, WAN. While local area networks are used to transmit data at higher speeds within close proximity, DWANs are set up for long-distance communication that is secure and dependable. SD-WAN, or software-defined DWAN, is virtual WAN architecture controlled by software technologies. An SD-WAN offers more flexible and dependable connectivity services that can be controlled at the application level without sacrificing security and quality of service. Service provider networks. Service provider networks allow customers to lease network capacity and functionality from the provider. Network service providers may consist of telecommunications companies, data carriers, wireless communications providers, internet service providers, and cable television operators offering high-speed internet access. Cloud networks. Conceptually, a cloud network can be seen as a WAN with its infrastructure delivered by a cloud-based service. Some or all of an organization's network capabilities and resources are hosted in a public or private cloud platform and made available on demand. These network resources can include virtual routers, firewalls, bandwidth, and network management software, with other tools and functions available as required. Businesses today use cloud networks to accelerate time to market, increase scale, and manage costs effectively. The cloud network model has become the standard approach for building and delivering applications for modern enterprises. What are AWS computer networking services? AWS networking services are designed to provide enterprises with network security. AWS infrastructure is monitored 24/7 to help ensure confidentiality and integrity and to meet the highest global network security standards. Network availability. AWS has the global infrastructure required to deliver high availability anywhere in the world. Network performance. AWS network services deliver high-speed performance with minimal lag time. How to use AWS networking services. AWS networking services are available for the following use cases. Networking foundations. These services offer solutions for virtual private clouds, VPCs, and for linking on-premise networks with VPCs. Amazon VPC, AWS Transit Gateway, and AWS Private Link provide optimized solutions to meet your networking requirements. Network security services like AWS Shield, AWS WAF, and AWS Firewall Manager protect your AWS cloud network and applications against cyber attacks. What is a firewall? Firewalls can be viewed as gated borders or gateways that manage the travel of permitted and prohibited web activity in a private network. The term comes from the concept of physical walls being barriers to slow the spread of fire until emergency services can extinguish it. By comparison, network security firewalls are for web traffic management, typically intended to slow the spread of web threats. Firewalls create choke points to funnel web traffic, at which they are then reviewed on a set of programmed parameters and acted upon accordingly. Some firewalls also track the traffic and connections in audit logs to reference what has been allowed or blocked. Firewalls are typically used to gate the borders of a private network or its host devices. As such, firewalls are one security tool in the broader category of user access control. These barriers are typically set up in two locations: on dedicated computers on the network or the user computers and other endpoints themselves, hosts. How do firewalls work? A firewall decides which network traffic is allowed to pass through and which traffic is deemed dangerous. Essentially, it works by filtering out the good from the bad, or the trust